Curve sketching then, let's have a look at the things to consider. It's easy to input x equals 0 and y equals something. Not so easy to do this. Sometimes it is. Stationary points, which we've already considered, that's a good thing to find in order to sketch a curve. And when x gets incredibly large, and also sometimes it's good to look at values of x where y gets incredibly large. So let's have a look at, with those thoughts in mind, let's have a look at this then. We've done this before. We know it's got a max at 2, 9 and no other max. So when x is 2, y is 9. So we can sketch that like so, and that's a maximum. Now when x is 0, if I put 0 in here, I get y as 5. So it goes through 5. And if you factorize it here, let's have a look at that. So x squared, I'm going to run a minus through this and let it equal 0. Minus 0 is still 0, so it's going to be x squared minus 4x minus 5. When does that equal 0 then? So I've run a minus through that and equals minus 0. It's the same as y is 0. So here we've got x 5 ones minus 5 plus 1 equals 0. X squared minus 5 plus 1 is minus 4 minus 5. So x equals minus 1 and 5. Those are the roots when y is 0, isn't it? So when x equals minus 1, which is here, y is 0, and when x equals 5, y is 0. So we can see, I've got a digital pen, so I'm going to do my best to sketch the curve. At the moment, we've got it going through there, maximum here, so it can't go any higher than that, and it must come back down. Now what happens as it goes along here? Well, as x gets to very, very large values, this term will dominate because it's large values squared, and it's a negative of a large value squared. So as x gets to infinity, it shoots down to minus infinity. And when x gets to minus infinity, if you put in minus 1,000, you'll get minus 1,000 all squared, which is plus 1,000 squared, which is 1,000,000, and it'll be minus 1,000,000. So as x gets larger and larger and larger, so y gets larger and larger negatively. And there's our curve with only one maximum turning point there. Next one then. Well, we know this was a cubic, and we know it had a maximum of minus 117. So I'm going to put that in here, minus 117, and 2, minus 10, and that was a minimum. Okay, so it's got a minimum here, and a maximum here. When x is 0, y is 10, so it goes through here. And there's no other turning point, so it's going to come down to here, isn't it? Now, there's no other turning point, so it has to just go up, doesn't it? And you can see that by this term dominating. So as x gets large, this term will dominate the whole of the other terms. And we'll get 2 times something cubed, which should be very, 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 very large. So it shoots off to infinity as x gets large, doesn't it? What about when x gets to minus infinity? We've got minus infinity cubed times 2, because this dominates again. Minus cubed is a minus, so it shoots down to minus infinity, doesn't it? And there's the curve. There's no other turning points on the curve. Okay, good. Next one. Let's have a look at this one. We know we've done this before. It's got a minimum at minus 1, minus 1. So that's a minimum. And it's also got a point of inflection. So it's going to come up here. It turns here because that was a turning point of inflection. And then it can't go back down because that would be a maximum. So it has to go back up, doesn't it? And as x gets large, this dominates and it will shoot up to infinity, won't it? Because that gets very, very large quickly. And here, when x gets large negative, again, this will dominate because it's the bigger power. Minus something to the 4 is positive, so it shoots up to infinity again on this side as well. So I've done dashed lines because I've got a digital pen. And there's the curve.